Ready?
Everyone say cheers.
All right, cheese, everybody.
Cheese.
There we go.
Fantastic. Hey, how's everyone going?
Great.
Good? Enjoying DevOps?
Yes.
That's really not loud enough, is it? Are you enjoying DevOps?
Yes.
Woo! Fantastic. So I'm Richard.
And I'm Raoul.
And we're here to talk about pragmatic functional refactoring with Java 8, which is that long list of words up on the slide there. Now, I think to a lot of people, your traditional functional programmer looks a bit like this guy. A very large beard, probably a bit of an academic, a look of sorrow in his eyes as though he's wasted the last 30 years of his life. And you know, that's what people's impression of functional programming is.
Well,
and you know,
take a look at your neighbor. If he's got a long beard, then chances are he's a functional programmer. So be careful.
Real people look a little bit more like this. Well, maybe not Lego people, but you know, people with jobs, work, you want to get your day job done, you want to get things accomplished, you want to get things productive, you want to achieve your goals and write software that works. And so we're here to talk a little bit about how you can use functional programming to achieve those kind of goals. So a brief outline of the structure of this talk. We're going to talk about a few things which we think are, you know, inherent to functional programming. Obviously, different communities all have different perspectives on what they think functional programming is or means or entails, but here's a few things which we think are relevant. First-class functions, currying, immutability, and optional data types. I'm going to be going through these one by one and then drawing some conclusions.
So a lot of words, you know, they're always useful to bring up during some important dinners. And we're going to shed some light on what they are.
Cool. So let's suppose you're running some kind of training company, some kind of training organization. And you have a situation where you want to find invoices from a specific client, for example, Oracle. So Raoul, you're going to be doing the coding here, you're going to be driving the coding. How do we find the invoices from Oracle?
Well, Richard, this is a very easy task. So if we want to find the invoices from Oracle, we're going to get a list of invoices as a parameter to a method. We're going to create, you know, a container that will contain all the invoices from Oracle. One by one, we'll iterate to each invoice, make sure that they're coming from Oracle, add it to the result, and we're done. So we can charge our customer 5 days of work, plus testing, plus support, grab a beer, and we're good.
Yeah, I'm pretty good. Oh, hang on. One more thing. What if we can have the same code that's got works with, say, Facebook?
Ah, very cheeky. Well, what we could do is take this method, right? Find invoices from Oracle, copy-paste it, call it find invoices from Facebook, change your condition in the middle, and then we're done. We can grab beers again and charge you lots of money. But really, I can predict already that Richard is going to be a bit cheeky and tell me that, well, business is probably going really great. We've got lots of customers coming in, probably Google and so on.
I'm going to be cheeky. I'm definitely going to be cheeky.
I knew it. So what we can do is we'll abstract the customer. So I can call for any requirement changes that involve the customer. So let's refactor a method for find invoices, introduce a parameter which is the customer, and we can now use that in our condition in the middle here. So now I can call for any cheeky requirement changes from Richard.
Just one more thing here, Raoul, one more thing. So these people we're doing business with, we might have different things which we're invoicing them for, maybe some training work, maybe some consulting work. Is there a way that we can filter out these specific types of work, say, for example, specify which training or something? Is that something that makes sense to you?
Well, you know, Richard, I've got exactly the right trick for you. Well, let's copy-paste a method, you know, standard trick. Introduce the parameter which is a suffix. So now I can find out any invoices that ends with a particular suffix. So if Richard tells me he wants invoices that ends with training, very, very easy. I can just use this method. If I want something related to consulting, very easy again. I can reuse the same method. What else have you got?
Aren't those both doing mainly the same thing? Both of those methods?
Yeah, they are. So let's take our software engineering hat on and let's think about code reuse. how can we reuse the same logic? Because after all, those methods are iterating through a list, applying a condition on it, and adding that to a result container. Well, please do not do this, ever.
And if you see your colleagues doing it, take them aside, have a quiet, polite word in their ear. Shout at them angrily.
So, we could merge those two methods to reuse the same iteration logic, but really, we will have a problem. This solution, first, is really ugly. Second, it doesn't scale, right? I'm pretty sure Richard is going to come back to me and say, well, what about the price of the invoices? What about the date? You'd like to combine different criteria to do the filter on. So this does not scale. So what can we do? Well, let's call a friend abstraction. So what we really need to do is to model this idea of a condition that we're applying on an invoice. So to do this, let's create an interface called predicate. So predicate is a terminology for something that returns a Boolean, and we can use it to represent a function that takes an invoice and returns a Boolean. So with this, I'll be able to check whether an invoice is for training or for consulting or whether it comes from another customer. So the next step to refactor a code is to actually use this predicate. So here we're introducing a parameter to our good old friend findInvoices method to take a predicate as an argument, and then we can refactor the condition to make use of it. This is very useful now because if I want to create any sort of predicates, then I can declare a class which implements this interface. We provide the implementation for the test method. So in this case here, given an invoice, we want to make sure that it's from the customer Facebook and it's related to training.
Is a class really the best thing we can do here, Raoul? Is there no way we can go any better?
It's a very smart customer, isn't he? Well, we've done actually something quite bad here. So we've traded concision. So a previous method were quite concise and readable for flexibility. So this method is flexible, but it's quite verbose. Every time a new requirement comes in from Richard, we need to declare this extra class every single time. So let's make use of Java 8. The first thing we can do with Java 8 is to use this functionality called method references. So here we define two methods. So those methods are defining the requirements from Richard. So in this case, is the Oracle from invoice. This method takes an argument invoice and then returns whether it's from Oracle. If we want something related to training, then again, we can declare this method is training invoice and provide the implementation for it. And with Java 8, we can pass this method directly as an argument to the findInvoice method. So we've done something quite interesting here. We've defined a method, and we pass it as an argument to an existing method. So that's one thing that entails first-class functions.
One more thing here, Raoul. We still haven't kind of got to the place where I can say it's both from Oracle and training without necessarily having some boilerplate going on. Are you going to solve that problem for me?
I will solve this problem for you, Richard, but in a moment, step by step.
Okay, step by step.
So the first thing we can do as an improvement is to use lambda expressions. So in the case where it's not practical to declare those extra methods, you can use this feature called lambda expressions, which allows you to define functions directly in line. So we can reduce the verbosity one step further. And really this idea that we've just seen here is what the crazy functional programmers guys call first-class functions. And it's the idea to define a function object. So we're all familiar with passing a number as an argument to a method or passing an object. Well, first-class functions means we can now pass functions directly as an argument as well. And this helps us code for requirement changes when you can really model the requirement changes by a function.
Lego. Who's a fan of Lego? Everyone. I think it's like a mandatory programmer thing to have played with Lego in your youth at some point in time.
And we're going to use Legos for what's coming up. So what's interesting with Lego blocks is because they're very granular, right? They're very interesting if you take them separately. But really the power of Lego blocks is when you put them together. When you glue them together, you can build really rich constructions. And it turns out we can do the same with functions. So for the remaining slides, let's think about function like a Lego piece. So if you look at this code here, what we want, so Richard is interested in invoices that are both from Facebook and are related to training. Well, it turns out we have already two functions that are doing this. What we'd love to do is to be able to glue them together to create a richer function. And that's what composing function means.
So how does that work?
Well, if you look in this example, we've got this new AND method here, and we've got another OR method here. So let's investigate how those guys work. If we look at the predicate interface defined in Java 8, you'll see code as follows. And immediately there should be something quite weird that you should notice. First thing is that, well, we now have implementation code inside interfaces. And that's a new feature of Java 8 called default methods. So the predicate interface is defined as follows. We've got a good old friend, the test method here. And here we've got this AND method, which is something new. This takes a predicate as an argument and returns a function as a return as well. And this is defined as follows. We call the current function, we do an AND with the function passed as an argument, and the whole thing itself is a function. So that's the little trick that goes behind it. The takeaway here is that you can pass function as an argument, but you can also return them. And we can take this idea a little bit further, and we're going to talk about function pipelines. Isn't that a very trendy word these days, Richard?
It's a pretty trendy word. You see a lot of people talking about pipelines and building these operations. But actually, it's the kind of thing which I think has been going around for quite a while. You see these very traditional kind of Unix-style do one thing and do one thing well programs that then get composed together with pipes in between them.
Totally. And in this example, we'll show how we can create a richer pipelines using Java 8 features. So the use case here, we've got an email, and an email contains a message. And sometimes, you know, you like to add a default header to it. For example, you may want to do some check spelling, you may want to add a footer, but really, you like to combine all those different operations. So in Java 8, using function composition, we can do something like this. So let's say we're interested in creating a pipeline that adds a header, then do a check spelling, and then adds a footer. We can extract the add header method here into a separate function. And then we can use endden, which is a method built in the function interface, which allows you to apply another function as an argument. So by using that, we can create this kind of a richer pipeline. And if you got another requirement change, let's say you want a more simple pipeline, then again, you can use the similar strategy.
So, let's talk a little bit about currying.
So Richard, we've got a lot of friends here at Devox, you know, coming from across the pond, and they use weird units like Fahrenheit, you know. So can we be friendly to them? You know, in Belgium, we use degrees, so we want basically an application that is able to convert from the normal units, like Celsius degrees, to Fahrenheit. Can you do that for us, Richard?
Yeah, well, you're right. Some people definitely do think the metric system is a communist conspiracy. And we do need to account for that kind of change. So maybe I'd write some kind of conversion function like this to when I'm converting between linearly scaled values. So I've got some amount that I might want to convert. I've got some kind of factor, which is the scaling on that amount, and I've got some kind of base value, which is how much I want to move that value up and down. And then I'd return a value that's multiplying the amount by a factor, and adding that base value on. So, for example, if I wanted to convert from the communist-infiltrated 10 degrees Celsius into the glorious 50 degrees Fahrenheit, it would end up being multiplied by 1.8 and adding 32. Is that all right? Is that going to internationalize successfully?
One more thing. One little more thing. You know, our friends also use other units, you know, like miles, even some different currencies. So what can we do for them?
Oh, that's a good question. Well, that conversion function will apply equally well in these other situations. So moving kilometers to miles, there's, you know, a fixed constant multiplier and a 0 at the end. And going from dollars to pounds, you know, you can multiply by a constant value and add 0. I heard this is how the financial crisis started.
Well, one more thing.
Okay.
So every time I need to convert from kilometers to miles, do I have to plug in those converting factors every single time? Surely we can do something better, right? Well,
there's an interesting question on that. we've got a situation here where we've got a kind of trade-off between abstraction and reuse. So abstraction being how do you write something that operates on different conversion functions in this case, and reuse, how are we actually going to reuse that conversion function in different places. But I think this is a solved problem in the functional programming space.
Yeah. So let's introduce a technique from functional programming called currying. So we all know the DevOps food is really amazing. So who's hungry? Yeah, so we've got lots of slides with food for you guys.
Fantastic. So one of my favorite types of curry is the good old thali. And the point about the thali is you get lots of little dishes from different areas potentially, but also different types of dishes. And you get the choice with the thali how you want to put those dishes together. So whether you want to mix your rice with some kind of curry here, or maybe choose a naan bread for a different kind of curry. And this is kind of similar to the situation of currying in programming languages. When you curry a function, you transform it into a different function, where instead of having a single list of arguments, you have separate arguments, which, applying each one in turn, returns you a new function.
So if I understand that we can mix them up just like we can mix those dishes together here to create more interesting functions.
It's less tasty, but it does solve business requirements.
Awesome. Well, we're talking about food, but how can we solve our actual problem then, Richard?
Oh, that's a good question. Let's look at a bit more code. So in this case, we might have a conversion function which takes the arguments factor and base, and which we've written in curried form just from the beginning. So it returns what's known as a double unary operator, which is a functional interface introduced in Java 8, which means a function from a double to a double. So if you want to convert from centigrade to Fahrenheit, we can apply convert with 1.8 and 32, and we get our double unary operator back, and then we can call this apply as double method on that conversion function, and we get our result. Does that make sense?
Yeah, very interesting. So how can I use this neat function programming technique then to solve the problem of converting to currencies or converting to different units?
The eating of the curry. Hopefully you have more fun than these people who've managed to completely fail at enjoying themselves whilst eating a curry, something I previously thought impossible. They look remarkably unhappy, and they're also making a huge mistake here in drinking wine whilst eating curry. In this case, in the code case, partial application is the eating aspect of the curry. Having split up this function, we can apply an argument to each of the individual functions, returning a new function, and that's what we call partial application. So to give an example here of how that would look in code, we've got our temperature conversion, our highly questionable dollars to pounds conversion, and also kilometers to miles.
So if you're wondering about the special symbol, the identifier, here from dollars to pounds, this is allowed since Java 7.
Glorious. In summary, when we're talking about currying is splitting up the arguments of our function in layman's terms, and partial application is the eating aspect of that. So putting in values that fill in some of those arguments and returning new functions.
Awesome. So let's talk about a third topic, really important of functional programming, called immutability. So in general, there's really two schools. There's one school that is advocating mutation, mutable objects. There's another school that is advocating for immutability. So what does that really mean? So mutable objects is what we are all familiar with. So once you've created an object, once you've instantiated a class, then you're still allowed to modify its state, right? So in this case here, we have a simple train journey class that has two fields, and we're allowed to modify those fields after we created an object by using the setters. But there is a different ways to do things, isn't it, Richard?
Yep. There's also an immutable approach. So in the immutable approach, we've taken our two fields and made them both final. And previously, where we had setters that change the existing object and return void, we have with methods that create a new object which have the other fields the same as the current object, and then set that one field to be different on the new object.
Yeah, and one of the benefits of this approach is that they are thread safe, right? We can send those objects to our threads, but we know that they're not able to modify them. So it kind of gives a bit more maintainability.
But Raoul, why should I be caring about immutable objects?
Well, let's look at an example to understand why we should care about it. So we're going to show you that you can actually reduce the scope for bugs by using immutability. And it turns out, a couple of days ago, Richard and I were giving a Java training course in Holland, and that involved a lot of train journeys, didn't it, Richard?
Yeah, it involved 4 train journeys, 4 hours, and 1 cancellation, Raoul.
As you can tell, he's still pissed off, hasn't moved on yet. So let's try and do something about it. So the use case we have is we've got several train journeys, and we like to link them up to form a longer train journey. And using the mutable approach, which we're going to call the destructive approach, it would look as follows. So in this diagram here on the left side, we've got the starting journey, and on the right side, we've got the continuation journey. And essentially what we want to do is to link them up. Using the mutable approach, all we have to do is to modify the start journey so it points to the continuation journey. Sounds reasonable?
Yeah, well, I don't know. It sounds like it involves trains, and trains tend to go wrong a lot in my life.
They never arrive on time.
Never run on time.
Well, let's look at how we can implement this mutable approach in code. So this code shows that. We've got a starting train journey, we've got a continuation train journey. If it's null, we return the continuation directly. But what's interesting here, the piece of meat really is the code in the middle here. This loops until we find the end of the journey, which we'll know because it ends with null. Once we reach that, then we can set the onward journey to be the continuation journey. So, quite straightforward code. So, if we take 2 train journey, we link them up, and we try to do that again, we expect to kind of get the same result, isn't it, Richard?
Yeah, that sounds like a reasonable assumption to make.
Well, who thinks this code will run fine? Yeah. Yeah.
You guys have been on trains as well, right?
So this code will actually produce a Stack Overflow error. And let's investigate why. Well, we start with 2 train journeys. Very good. We link them up. So that means we've actually modified the state of the first train journey to point to the continuation journey. And when we try to link those guys up again, the starting journey is different, right? So we reach here. We're going to go through every single journey until we reach the end, and we're going to link that up to the continuation journey. So essentially what we've done is to introduce a cycle. So you take your train, and you're going to go round and round and round in circle. The functional style approach is a bit different. It says, well, instead of having to change the state of objects, so the users will not expect it, instead we're going to copy those objects. So in this case here, instead of modifying the start journey, we create a copy of it, and then we can link that to the end journey. And this is great because if someone is still using the starting journey to do some processing, we're not actually modifying that unbeknownst to him. If we want to implement that, there's quite a concise way to do it using recursion. So we start here, we create a copy of the train journey, and then recursively we can say, well, please copy all the start journey. Once you reach the end, just link the continuation journey.
So, having established that immutability is potentially quite a useful feature for reducing the bugs, it's worth noting that there's a few other different things which you might want to have a look at in this area. So, who's familiar with domain-driven design? A few people, somewhat catching on. Okay. The domain-driven design guys view all value classes, so classes who are basically a bag of fields, each of those fields with a value, as being things which should be inherently immutable because they're exact cases where you get these kind of bugs cropping up. A few of the improvements in core Java libraries over the last few years have been focused upon writing classes or moving to a more immutable style. So the date and time library in Java 8 follows this model exactly, of having immutable classes nearly everywhere.
But it's worth mentioning, it's been good practice for a long time actually. If you look at the integer class or the string class in Java, they're all immutable as well.
Yep. Also, the current details of the value types proposal seems to be focused on having immutable values. If you want to go and take this approach and use it in your software today, there's a bunch of tools which you might find are useful for solving these problems. So, for a start, the final keyword is useful, but it only really bans reassignment. You can still put a mutable value into a final field, and you'll still have a mutable class going on. JSR 308 allows you to put annotations anywhere there was a type, and that means anywhere, and it might look a bit crazy. But this also gives improved opportunity for people to write annotation processors, and a couple of the people from MIT have shipped ones which give you really, really good, concise checking of immutability. There's also a project on GitHub called Mutability Detector, which lets you write tests which say, hey, check that this class genuinely is immutable. And there's always good old find bugs, which you can say, hey, we'll annotate this class as being immutable and find bugs or raise an error if it's not.
So, in a nutshell, immutability kind of reduces the scope for bugs, so it's a good practice to use in your own code base. So the next topic is another fancy functional programming terminology. Always good to bring those guys up during dinners. We're going to talk about optional data types.
Cool.
So, don't we all love this, Richard?
So who's had a null pointer exception? So who's had a null pointer exception in code in production? So who's had a null pointer exception in code in production on a 5:30 on a Friday afternoon, just about when you're going to the pub?
Well,
It's like the same people. It's guaranteed to come up at that point in time, isn't it?
you guys are in luck. With Java 8, Oracle has made a huge effort to help us go to the pub on time.
I'm sure that was their exact motivation as well. Cool. So yeah, so we're going to have a look at a trick to try and reduce the scope for null pointer exceptions. So, let's suppose you're a programmer, in this case our good friend Wally, and Wally's got some code like this, and he sees a null pointer exception. And the code is taking a person object, and it's calling getCar, so there's potential for an MP here. It's calling getInsurance, so that's checking the policy on the car, and that might be null. Not everyone buys insurance on their car, even given the law. So there's a potential MP there. And they call getName to find the name of the insurance policy provider on the insurance policy, and maybe you don't know what the name of the policyholder is, and that could be null as well. Now, poor old Wally started trying to debug this code because he saw an MP on this line. It drove Wally insane. So insane that he ran away from his job and has most recently been seen hiding in crowds of people in order to escape trying to debug this code. So, what could Wally have done? Well, he could have gone ahead and tried to undertake massive amounts of defensive checking. So he could have said, well, that person could be null, so we'll have a null check there. Well, that car could be null, so we'll have a null check there. This insurance policy could be null, so we'll have a null check there. And then we'll just return the statement that there's, we don't know what the insurance is otherwise. But what do you think of this code, Raoul? Are you enthusiastic about it?
Well, I think that's one of the reasons why we can't find Wally anymore, isn't it?
Yeah, Wally's not too enthusiastic about the solutions to this problem either. So, Java 8 introduces optional. You can think of optional as being a bit like a container or a bit like a collection in a sense of something that can only hold 0 values or 1 value. And what that means is whenever you see an optional field or a method that's returning optional, you can look at it and go, well, we've explicitly modeled the problem. We've told the client of this code or any developers reading this code that this code may have a value or it may not have a value. It's easier to maintain this code because it's easier to understand what the potential problems are and what can go on with it. It also means that you need to actively unwrap the optional in order to do stuff with it. Or should try and actively unwrap the optional in order to do stuff with it. And there's a bunch of methods that act on optional in order to let you process values within optionals and work on them. This also results in fewer errors because you won't have the null pointer exception case. Okay?
So how can we use optional then to refactor a model, Richard?
Well, let's take our model and say, well, people don't necessarily have cars, so that could be optional. Cars don't necessarily have insurance policies. They may not have been driven out of the dealership yet. And we're going to say in this case that our insurance policy has a name, so definitely has a name. Then we can use the map function on optional, which is going to take a function in as an argument. And that will let us take a value that's within an option, apply the function to the value in it, and return us a new optional with the result in. And if there's no value in the optional, it'll return us an empty optional on the other side. Does that make sense?
Yeah, that's great. So how can we refactor our previous code into making use of map?
Great question. So we're going to take the person, and we're going to take a person, and we're going to call the of nullable factory method, which will give us an optional with a value in if we have a person, and it'll give us an empty optional if it was null. Then we can map that person into a car, and we can, something's gone wrong here, hasn't it? The problem with map is that when you have methods that end up returning optional, and you're calling map, you're going to get a situation where you have an optional of optional car, and this is going to end up with a compile error. So what are we going to do about that?
Well, you know what? I know exactly the right person to call.
It's not a Shiba Inu dog, is it?
It is. It is.
Okay.
So let's call him.
So flat, such map, much optional. Wow.
So it sounds like we're going to talk about flat map.
Yes, flat map. So this problem's solved entirely by flat map. And in the situation of the flat map, we can apply a function which returns an optional, and instead of having an optional of optional, we'll just get that optional value itself. Sounds good?
Yeah, perfect.
Wow.
So let's see what the code looks like.
Respect the knowledge of the dog. So our refactor code now takes a nullable person, flat maps them into their car, flat maps that car into its insurance policy, maps the policy into its name, and then if we're in a situation where there's no value in there, it provides a default value of an unknown policy. Okay? So in this case, we've learned that consistent use of the optional data type replaces uses of nulls, reduces bugs, and makes it easier to read and understand code, documents it explicitly.
Fantastic. So let's summarize a little bit what we've learned. So we introduced 4 fancy terminology: first-class functions, which is just the idea of being able to pass a function as an argument to an existing function, or even returning them. We talked about currying, which is a way to split the argument of functions. We talked about immutability, which is a way to reduce the scope for bugs. And finally, we talked about optional, which is really a way to kind of prevent null pointer exceptions.
Fantastic. So hopefully you've now moved into a situation a little bit more like these people. You've still got a day-to-day job, you've still got solving problems, but you've got a little bit of functional in you. Yeah, just a little bit.
So here's the plug slide. So Richard and I, we actually wrote some books. So myself and Mario, somewhere here.
Oh, there you go.
Mario, hey. We wrote book Java 8 in Action. Richard wrote the book Java 8 Lambdas from O'Reilly. Do check it out. Both books are equally great.
Yep.
And we also give Java 8 training, so feel free to go on this URL to check this out. And we're now going to take questions.
Any questions?
Yep.
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 Oh.
Okay, you're an author. You already know the answer.
Yeah, I know me and Raul discussed this already, but I wanted to know your opinion about it, Richard. We talked about the optional, and one problem of the current optional implementation is that it doesn't implement the serializable interface.
Ooh, a controversial subject.
And I wondered why they made this decision, and I don't have an answer.
So I also don't know why they made that decision, because I didn't make the decision. But I'm going to speculate, putting myself in the position of making that decision, and claim that serialization is a bit of a fundamentally broken mechanism in Java anyway. It's the kind of thing where if you do want to serialize an object into some bytes, you don't necessarily want to have that coupled to the runtime, the language, all this other thing. You might want to interact with other systems that don't work in Java, and the serialization mechanism doesn't cope very well with that. You may want to change the mechanism by which you do serialization over time as your business requirements change or your performance requirements change, and serialization is quite a hard-coded thing. So I guess to me, it's not like why doesn't optional implement serializable? It's kind of like, why do we still try and go with serializable as a solution anyway? It's not, I know there's a lot of people out there who do use serialization, but serialization in Java is not a great mechanism for solving the class of problems which it's trying to go for. Does that make sense?
Yeah.
Can you go back to the slides on currying? The one where you go talk about eating curry?
The picture.
The picture of the very unhappy people.
This one, yeah?
No, the next one.
Okay.
No. The one where you have different instances of double unary objects.
Oh, sure, when we're creating the different converters.
So that one. So you can then invoke something on the convert C to F.
Yeah, because
you call apply as double.
Yeah, the double unary operator supports the this method here called apply as double, so you can just call it. So you can see this as a factory that creates converters basically in those objects themselves.
Is that okay? Fantastic. Any other questions? Hi.
The optional is a great solution for the null reference problem, right? You noticed that you didn't use the M word to call the optional, okay?
Yep.
Yeah, we try to avoid that, yeah.
I respect that. I noticed that Java 8 doesn't have a solution for the exception problem.
Like a try. So the question is, optional is great in Java 8, but what about exceptions? Can we have something like the try M-ish word from Scala?
Right now I check if something is null and I try and catch.
Yeah.
And I can replace the first with optional and the second I can replace with.
So you can implement that library yourself. And if you go on GitHub, you'll find that there's a guy called Benjamin Weber. I think it's Benji Weber is his GitHub username, who has a bunch of kind of project called Expressions that has a bunch of toy play around things. And he basically has a try catch as an expression that implements effectively a kind of an error handling system in the same vein that you've just asked for. So I'm sure someone will libraryize this properly. But you know, you can just steal Benji's code. He's not going to mind.
Yeah, there are several examples on the net of this, but it's so elementary. Why didn't they just include it in the library itself, in the language?
I'm not sure that it's necessarily a thing where you want to say, this is elementary, why don't they do this? So I'm not Brian Getz, but I'm going to channel him for a moment and say a thing that he always says, which is everyone wants like that one step further, and then someone else will want that one step further beyond you, and eventually they'll need to add everything to everything, and they don't want to do that. So they draw a line at some point in time. I don't know whether that was the right place to draw the line. It's a pretty good place to draw the line. But you should probably ask him personally what he thinks on this matter and on whether it's the right place to draw the line for him or why they didn't do that specific thing. But there's like a million features that fall into that, like this is the next thing that we can do, and you can't do all 1 million of them.
So the main motivation for optional was the streams API introduced in Java 8 needed something to model the absence or existence of a value, so that's the reason why it's introduced. The problem now is there isn't a compelling use case enough to introduce something like try at this stage.
Okay. Any other questions?
Coming back to the serializable and optional thing.
Yeah.
Correct me if I'm wrong, but if you're doing your business logic with CDI and your
Right.
means, they have to be serializable, right? And so does that mean you can't use optional with CDI?
I don't know. I don't know. I personally don't use CDI. Any other questions?
Manny?
Manny?
Can you pass in the default value in case the value is null? Empty list.
Yes. Yes, so we actually had a code example of that earlier where it's called or else is the method you need to call. So you say or else, here's the value.
And you can even throw an exception if you want, or even pass a lambda expressions using or else
Yes.
get.
Okay, cool. Any other questions?
Difficult to see, huh?
I don't know. Is there a guy in the middle? Yeah. Shout. Sorry, can you repeat that again? Do we think returning optional for something? I think if you've got a situation where you've got the core business logic of your domain and you want to model that in a way that you have a value that might be present or might be absent, then optional is a great way to go. I think that's perfectly reasonable for having fields, and I think you're on board with the optional for fields.
So I think optional is great for library design. For example, your method might returning something that is optional, so the intended is great. For fields, there's a bit more controversy, I think.
There's more controversy, but definitely some situations where it's applicable. Okay. Any other questions? Hi.
Can you please go to the slide where the flat map was?
The one with the dog or the one with the code? This one.
This one, yes. Do you really think that this code is easier to understand than the old plain old or if else or something?
It's a perfectly valid question, and I think it's code which is not easier to understand when you first read it. Sorry, the question was, do you think this code is easier to understand than massive amounts of defensive checking? And I was saying, I think it's the kind of code which is not necessarily easier when you first read it, but I think it's a lot less painful to deal with as you maintain it and once you're more familiar with the pattern. And less error prone.
So the benefit is, with the null checking, you may forget to actually check whether it will return null or not. With optional, you have to actively cater for the case whether there is or isn't a value. So that's one of the major benefits. You will not get those bugs. It's less error prone. From a readability point of view, I think in general what people say is when they've used the pattern a few times, when they're comfortable with it, then it's not an issue anymore. It's a question of taste as well.
Yes, if I can add something, you shouldn't confuse the familiarity with readability. This is more readable, but it's less familiar. Yeah. This is the problem.
Fair enough.
Yeah.
A question of the same code, because what bothers me is this flat map, and map, right? Does it make sense that map would just do flat map underneath? That's it. We have to have mass only.
They're different operations. So the type of a map is you've got an optional of t, and you're going to return an optional of u, and you're going to take a function from t to u, and your type of flat map is going to take an optional of t and is a method on optional of t and going to return an optional of u, and is going to have a function from t to optional of u. So you can't have it typed and support both use cases, right?
Yeah, yeah. And this pattern happens with other classes in Java API, such as streams, CompletableFutures as well. So once you get used to them, life will be good, I think. I think serialization is one of the issues here.
Yep.
So from an API design point of view, it's fine, but because serialization, there's a bit of controversy whether fields should be optional or not.
Yep.
Yeah.
Have you compared the optional implementation in Java 8 with the Google Guava's implementation? So is it worth, from your point of view, is it worth to migrate from Guava to native?
I think it's always worth trying to minimize the amount of dependencies you have in your application. Anytime you've got some third-party library, That third-party library can provide you with some value, some repeated boilerplate code which you didn't have to write yourself. But it's also a situation where you're very dependent upon the ongoing maintenance of practice of this code, the compatibility of this code, being able to still get access to it in future, things like that. And you're also in a certain way coupling your application to that library by using it. Now, if you can minimize the number of those dependencies, that also potentially has a value. I'm not saying don't ever depend on any third-party stuff or anything crazy like this, but often people go, hey, there's this great thing in this great library. I'm going to go and use this library to get this thing, but they've also got a cost of using that library, which is kind of more maintenance type of thing. So if you're in a situation where you can use core library features where they're appropriate, that's a great thing. And I think certainly a lot of, so I've previously written code which uses Guava, and Guava's great and has a bunch of useful features, but a lot of the reasons why I would use Guava are things which actually get replaced with core libraries in Java 8. So it's actually an option to not just replace the optional, but replace that entire dependency and, you know, simplify your world one step at a time.
Good old friends map and flat map.
Cool.
Yep.
I'd like to add that the Guava guys actively encourage people to, that for example use Java 7, not to use the features. I know that we're now talking about Java 8, but they really want people to use the JDK versions whenever possible.
Yeah.
Java.
Yeah. Cool. Manny again.
So that was a good question about readability, and I see that more when a lot of these flat maps are used with streams and stuff like that. So I was wondering, I'm not suggesting anything, but map is a lot more technical term, and I like the DSL you guys use, like or and or else.
Yeah.
And if it was possible to alternate these with that, so again you'll say, okay, we're adding more boilerplate, but if we can switch between the two when we want to, so make it more readable, and use things like terms like these rather than use terms like.
So it's an interesting question because actually Richard and I, we were actually debating a little bit about this. The completable, the question is map and flat map really, there should be perhaps different names that are more familiar to us, more domain specific. Is that? Yeah.
And it's not just map and flat map, it's that whole family of functions that are sounding very functional.
Yeah.
Taking away the readability in many cases.
Yeah. So the CompletableFutures class actually calls map and flat map with different names. It's called then combine and then compose, which are a bit more meaningful. And again, it's a tricky one. I think as Maury is saying, once we're familiar with it, it's okay. But the first initial step might hurt a little bit, and afterward, life is good, I think. But
I mean, on that note, I personally don't like the fact that CompletableFuture has a different set of names for the same conceptual thing. Regardless of what those names are, it's a shame there's an inconsistency in the APIs between things which are conceptually doing the same thing. As to map, flat map, I'm personally reasonably happy with those names as they are. As to whether you find them familiar or unfamiliar, that's a different aspect altogether. With things like this, I think it's a situation where there's like never going to be a perfect answer, right? You're never going to have a name which everyone's entirely happy with. And none of the proposals that people are making on these things are like, you know, completely awful, are they? None of them are like, here's the red wall method or something like that, and it's going to be doing a map. And none of them are like in a crazy situation that you see some languages where they have operator overloading and then it's like tilde star, you know, it's some ludicrous operator that has no semantic meaning at all. So, you know, I'm pretty happy with that choice. I
mean, now it's in the API, so we've got to live with it.
Yeah.
It's not going to change.
Cool.
Any other questions?
Okay.
Yeah.
The original motivation was about this guy not finding where the null pointers came from, right?
Wally.
Yeah, Wally.
Okay, Wally. Now, suppose Wally finds no value at all. He will still have trouble finding where it came from, right?
Well, I mean, the situation that we were encountering, it was a bug, and you should be saying that there's no insurance policy. That's a perfectly reasonable thing. The person has no car insurance. and there was in both the defensive checking case and in the optional chained case, there was a default value provided in that case, in the scenario where there was no insurance policy.
Okay, but suppose you were expecting to have a reasonable one, where did the default come from? Where did the chain come from? It's the same question.
I'm sorry?
Where did the lack of a reasonable value came from in the chain of the flat maps and the maps? It's the same question as where did the null pointer came from?
I don't think it is the same question. Because in the null situation, you can very easily just call the method, call the method, call the method, and ignore the fact that there is an absent case. Whereas when they're returning optional, it's explicitly documented that there's an absent case. And that's a thing which you as a programmer sit there and go, oh yeah, I've got to deal with this case. I've got to think it. I'm not saying you can't write it that way the other way. I'm just saying by giving yourself that kind of hint that, yeah, I need to think through this case, it's the kind of thing where you're less likely to write error-prone code. Does that make more sense?
The only thing that your example is very simple, so it didn't show the possibility.
Okay.
Eventually, you have the possibility to write your defenses in a more precise way. So.
Okay, cool.
Anyone else?
Cool.
Yeah, feel free to come talk to us. We'll stick around to answer any other questions.
Thank you very much.